Hi, Tommy Clayton here, an OpenSciEd middle school teacher and lesson writer. Excited to share lesson 2 from unit 8.3, the Forces at a Distance unit. This lesson has a really cool hands-on investigation where the kids make an electromagnet. And there's some parts that can be a little tricky as far as safety goes. So we're gonna dig into those, make sure that you're in a good place and set up, ready to make sure that everything goes smooth for that investigation. We are going to talk a little bit about how we got here, this lesson at a glance, some of the real key moments, including that investigation, and then some tips and tricks and material management. So let's get into it. All right, let's remind ourselves how we got here. So we are coming off of the anchoring phenomena, lesson 1. Last time we were together, we figured out that there's a coil and a magnet, and somehow those work together to make a part of the speaker vibrate. Maybe it's like that foam surround or the cup, whatever it is, and they don't have to touch, and that's really weird. And so in this lesson, we're wondering more about what can a magnet push and pull without touching, right? What kind of things can a magnet move? And so let's take a look at this lesson at a glance. This lesson is a 2-day investigation lesson. It's going to take you about 30 to 45 minutes to get set up. There is 2 great hands-on investigations that the kids will do. There is no devices needed, and there are no real additional related videos to prepping for this lesson. Okay, so let's take a look at this lesson at a glance. So over the course of 2 days, there's this first big chunk where we are going to figure out that magnets can move things that are made of iron. And then we're going to close out day 1 by starting the second chunk. And that's really around trying to figure out that the coil itself actually acts like a magnet when it's hooked to a battery. And so the investigations across those 2 days will help us to figure out these big ideas. So on day 1, we're going to figure out that some metals can be pulled magnets like iron, and some can't, like copper. And we can get magnets to do some interesting things. We can make them attract one another or repel one another, depending on the way we flip those magnets. And then on day 2, we're going to figure out that there's actually some forces between the magnet and the coil when that coil is actually connected to the battery. And we can get both the pushes and the pulls between those, depending on how we orient things. So let's look at some key moments in this lesson. All right, so after we navigate in and think about the different things that we want to investigate, we are going to investigate magnets with a whole bunch of different objects. So you can see those on your screen. And what we're going to do is we're going to take that magnet and put it real close to the object and see if we detect a push or a pull. We'll work with a partner to see if we do that. You want to make sure the kids are doing that real slow to see if they can see things. And as they are doing this, they're going to record it on their handout. And interestingly enough, they're going to see that they can pull the paper clip, the nail, the compass, they can actually push or pull. And then the other magnet, they can push or pull. The compass one, they might not see right away, and you may want to, lean into that a little bit. Ask them if, they might say they can only pull it, and ask them to play around a little more, see if they can get that push as well. And we are going to then take these results and form a scientist circle and have our building understandings discussion. And so they're going to name, students are going to come, and say oh, here's all the things that I was able to move. And likely kids are going to start to say I think it has something to do with what they're made of. And that's when you're going to be like, oh, you're interested in that? I actually have some data on that. And you're going to supply them with this handout that you see on the screen where they can actually look at what things are made of. And so during this discussion, that's where we're really going to figure out that the magnet can push and pull things made of iron or with a lot of iron in it. And it can't really do anything with the copper, the aluminum, or the zinc. And this is also the moment where we are going to kind of find out that a compass is kind of like a magnet. We're not going to name sides or north and south or any of that yet. That's going to happen later in the unit. But we are going to kind of recognize that the compass has sides just like the magnet does. And that's kind of interesting. Okay, so we sort of navigate at the end of this discussion to be hey, the magnet didn't move the copper at all, and we thought maybe it did. And so there's like this exit ticket where we're going to ask kids, like, well, what do you think maybe we need to change about the coil? And you're going to look for kids to say something like, they want to connect it to electricity or, whatever the case may be. They don't have to necessarily use that word, but they're going to name that. And so when we come back on the next day, we're going to share like, a bunch of students had some ideas to connect the coil. And so I have some batteries today. We're going to do that. And so what they're going to do is they're going to take that coil, hold it up to the magnet, and they're going to try all the different orientations with the magnet and the copper coil. So they're going to kind of like put them together and notice if there's a push or a pull, and then they're going to flip one over and do the same thing, and then flip the other and do the same thing, and then sort of flip both. So the handout will help them to try all those different combinations and record those pushes and pulls. Then we're going to jump back into a scientist circle and sort of put this all together and model that, between the magnet and the coil of wire, we are able to get pushes and pulls, and we're going to model those forces. So this is a callback to 8.1 if you've done that with students. If not, you can sort of introduce this idea of using arrows to show the forces. And we're going to kind of name this idea of like when they're pulling toward each other, that's that attractive force. And when they're pushing away, that's that repulsive force. We're also going to get on the table that we saw the coil of wire move. And so it must be getting some kinetic energy. There must be some transfer there because we're able to see that coil move back and forth. And again, this might be a callback to 8.1 and 8.2 if you've done that with your students. All right, so where we go from here is the next thing we need to think about is like, well, if the coil of wire is moving and it's getting some type of energy, like where is that coming from, right? How is energy being transferred if things aren't touching? So we're going to investigate that in lesson 3. All right, so let's talk a little bit about some tips and tricks for this lesson. Part 6, when they're doing this electromagnet investigation, there's a couple things you really want to keep in mind. One is the wire is thin, so it will heat up pretty quick, okay? So we want to make sure that the students are not testing for long periods of time and they're not leaving it connected for long periods of time. You'll see in the picture that we use some tape to secure that. And this is really just like a quick, test the side of the magnet, disconnect it, give it a moment to kind of cool down while you draw on your handout, and then do the next one, okay? We want to make sure that we're really aware of that we're very clear with students, that it can get very hot. And if we are not careful, somebody could get a little bit of an injury. So we want to make sure that we are attending to that. Make sure you're trying this out yourself. The disc magnets are a little bit tricky because of the way that they're oriented. And so sometimes the coil of wire can actually like flip around and kind of go to the back of it. So try this, practice it so you can help guide the kids. Again, we want them to just see whether it's getting pushed away or pulled toward it. And so this is kind of a quick sort of thing where we want to just see what we notice. If you make the leads, the wire coming off of the coils longer, it's going to be easier for them to see that movement. So you'll see in the image, the leads are kind of short. I would make them a little bit longer, maybe even double that length for students to really see that magnet move back and forth. In the lesson, it calls to put stickers on one side of the coil and stickers on one side of the magnet so you can keep track of the sides. Unfortunately, the stickers seem to fall off with middle school kids, so you may want to think about like using nail polish or like a more permanent marker to color in one side of the coil. The stickers will work well on the magnets. That's not usually an issue. It's just a coil that they can kind of fall off on. All right, let's talk a little bit about the words that you're going to introduce. So we are going to earn some words. That is attraction and repulsion. And so those you heard in that Building Understandings investigation in part 3 on day 1. And then we're going to call back from previous units to words like force and kinetic energy. We have a couple posters in this, so you may use the ideas for investigations to navigate in. It doesn't necessarily call for that, but it can be helpful, particularly because kids are going to say they want to try magnets with a bunch of stuff. And then we're going to create that magnet and coil forces poster that you saw where we are naming the different kinds of orientations and forces that we can have between the magnet and the coil. All right, that is going to do it for us. Enjoy this investigation. Really help your kids to be careful so that nobody gets any small injuries. and come back and join us for lesson 3 when we find out a little bit more about what might be going on between the magnet and the coil or another magnet when things are not touching.